We've discussed circles, parabolas, and ellipses, and now we're going to look at hyperbolas. A hyperbola is defined as the curve of intersection between a right circular conical surface, like this double cone, and a plane that cuts through both halves of the cone. So as you can see, we have two branches for our hyperbolas. Here are a few real-world applications of a hyperbola. The mathematical definition of a hyperbola is the set of all points P such that the distance between P and the foci on both branches stays constant when you take the difference between them. The symmetry of a hyperbola all rests around the center of the hyperbola. Now on the axis that contains the center, we also have the focus and the vertices. So we have two foci and two vertices. Now this axis is called the transverse axis. The other axis is called the conjugate axis. As you can see from the diagram, a hyperbola has two asymptotes as well. If our hyperbola is centered at 0, 0 and is a horizontal hyperbola, then that means our transverse axis is going to be the x-axis, our conjugate axis will be the y-axis, and as you can see, our foci and our vertices lie on the x-axis. And if you look at the equation, the biggest difference between a hyperbola and ellipse is that the hyperbola has a minus sign in between our x squared and y squared terms. Now a squared is underneath the x squared, but that is because a squared is always going to be underneath the transverse axis. So since x squared is our transverse axis and we are a horizontal parabola, a squared will be underneath x squared. This does not, however, mean that a will be bigger than b. So unlike the ellipse, a could be smaller than b. Whenever we have a vertical hyperbola, you can see that our transverse axis is now going to be vertical and our conjugate axis is horizontal. So our foci and our vertices now lay on the y-axis whenever we are centered at the origin. Now notice in the equation here, a squared has not moved. It is now still the first term. So a squared will always remain underneath the first term for a hyperbola. And that will tell us what is the orientation of our hyperbola. So if y squared comes first, that means we're a vertical hyperbola, and if x squared came first, then we would be a horizontal hyperbola. So just like the other conic sections, we can shift off of the origin being our center. So the equation of our conic section here, the hyperbola, will change. Now keep in mind we still have minus signs in between, and our first term here will always have a squared. In all of the diagrams of a hyperbola, you see this rectangle formed in between the two branches. This is called our central rectangle. Now the central rectangle is going to help guide us to graph the hyperbola, and the diagonals of the rectangle are actually going to be our asymptotes. The dimension of this central rectangle will always be 2b and 2a. So depending on the orientation of our hyperbola, that might be 2a or 2b if we are vertical. Now the slope of our asymptotes will also depend on the dimensions of this central rectangle. So that's going to be our quick, easy way of finding the equation of our asymptotes. Just like a parabola, the foci is always found inside the curve of the hyperbola. Now the equation of finding our foci is the Pythagorean relation c squared equals a squared plus b squared. So here you can see that the distance between the center and our conjugate axis here is b, and then from the center to the transverse axis where our vertex is a, and the distance here c will be the same distance from the center to our foci. So now we want to write the equation of a hyperbola with the given vertices and focus, and we're going to be centered at the origin 0, 0. Now because our vertex and our focus are both located on the x-axis, I know that I have a horizontally oriented hyperbola, and since I'm at 0, 0, this is going to be our standard base equation. So I need to find a and b. Well, I was given a and I was given c. So using our Pythagorean relation, 5 squared equals 4 squared plus b squared. Solving for b squared equals 9. So plugging everything in, we get x squared over a squared, which is 16, minus y squared over b squared, which is 9, equals 1. So remember, it's always equal to 1. And for a hyperbola, this first term here always tells me the orientation. So since I am horizontally oriented, it has to be x first. To find the center, the vertices, the foci, and the asymptotes of this hyperbola, I must put it in standard form. So I'm going to divide every term by 63 so that it's equal to 1. So y squared over 7 minus x squared over 9 equals 1. Because my y squared term is first, I know that I will be a vertical hyperbola. And underneath that term here is always my a squared term. So a squared is 7, which means a is going to be the square root of 7. B squared is 9, so b is going to be equal to 3. So to find my center, if I look at these terms, it's supposed to be y minus k and x minus h, but I do not have any terms subtracted, which means my center is 0, 0. My vertices will be on the y-axis because I'm a vertical hyperbola. So my vertices will be 0 plus or minus a, so plus or minus the square root of 7. To find my foci, I must use my Pythagorean relation. C squared equals a squared plus b squared. So c squared equals 7 plus 9. So c squared is going to be 16. So c is going to be 4. So my foci and my vertices are always on the same axis, so that's going to be 0 plus or minus 4. Now my asymptotes are going to be the lines that are created by the diagonals of my central rectangle. All right? Now that means I must go to my center. I'm going to go up A and over B. Okay? Up A and over B. So the slope of that box will be plus or minus A over B. Now it's always plus or minus because I have two asymptotes, one with a positive slope and one with a negative slope. For this hyperbola, we're already in standard form, so we don't need to divide through by anything. As you can see, our top terms here have something subtracted, which means that we are shifted from the center being the origin. So my new center, this is always y minus k and x minus h. So my center is HK, so I have to switch that around a little bit. It's going to be 3, positive 1. Now my vertices are going to be determined by a squared, which remember for a hyperbola is always the first term here. Because I'm underneath the y term, we are vertical hyperbola. A squared is going to be 25. B squared is going to be 144. So A is 5 and B is 12. So to find our vertices, since we're vertical, we're going to go up 5 from our center. So if we're at 3, 1, we want to go up 5, so we're going to be at 3, 6. And then we have to go down 5, so we're going to be at 3, negative 4. So our vertices are going to be a little bit different when we're shifted off of the origin. It all depends on your center. Now to find our foci, we have to use our Pythagorean relation. So we have 25 plus 144. So we get 169 for c squared. So c is going to be 13. So I'm going to go up 13 from our center and down 13 from our center. So up 13, we're going to end up at positive 14, and down 13, we're going to end up at negative 12. Now our asymptotes here, if you locate your reference sheet, we have a formula that's going to be plus or minus. Now because I'm going up and then over, so A and then B, our slope is going to be 5 over 12. And then it's always x minus h, which is going to be 3. And then we're going to always add our k plus 1. So that's going to be our line there for our asymptotes. Alright, so now give these problems a try and put your answers in your notes.